So here I have my BeagleBone Black I'll be using. I won't cover that, you know how it works. And then this is the SensorCape that I've been working on. This is version 0.2. So this is not the final production. If you decide to order it, this is not the version you'll be getting. This is just my first version of test boards. And you can see up here I've got a few things missing. So I didn't install the LEDs. I decided that since there was already 4 on the board, that it would be kind of redundant to add 4 more on a cape. So that will not be on the final version. If you look closely, you can also see that I did not install the light sensor, and that was not really by choice. That's because I ordered samples about a month ago of that part, and I was told that they would arrive shortly, and they never came. So I'm a little disappointed in Intersil for that, but oh well. You also see I'm missing 3 of the buttons here. That's because when I designed the board, I accidentally used too large of a footprint for the buttons. Well, I didn't design it, so that's the reason I used too large of a footprint, but I'll fix that on the production version. So for now, I just kind of rigged one on there and just to see if it works. I'm not really even sure if I'm going to include the buttons on the final version, but I wanted to play with it to see how I liked it. Then you can see right here we have the 9-axis sensor. That's your compass, gyroscope, and magnetometer. All those are integrated into one package, so I'm really looking forward to playing with that. And then right here we have the non-contact temperature sensor. That's a really tiny chip scale package from TI, and it uses a infrared thermopile to detect temperature of objects that are far away. So that's kind of cool. I'm looking forward to playing with that as well. Up here we have the pressure sensor. That is from Bosch, I believe. And that's good for detecting changes in altitude or, I mean, anything that causes a change in pressure, but it's most often used for an altitude sensor probably. And then right here we have the humidity sensor. I'm not sure how I feel about this one. It was mounted incorrectly by the assembly house that I used, and not their fault. I was unclear in my markings on the board, so I don't fault them for that. But it is upside down, so I'm not going to be able to use it in this test. And that's actually okay because I've been considering taking that off the board. I think it's about a $10 part, and I just don't think enough people are going to use a humidity sensor to make it worthwhile. So I'm probably going to take that off the final version unless a lot of people have an issue with that. And then right down here in this bottom corner we have the infrared sensor, and that just takes, it operates on a 38 kilohertz carrier frequency and converts inputs to a digital signal, sends that to a GPIO pin down here on the board. And then you see this dip switch here and an EEPROM. Those are for the Cape EEPROM, so you can tell the BeagleBone what position you have the cape in. So you can have 4, I believe it's 4 capes on the BeagleBone. This tells you which cape you're accessing. And that's actually not connected to the right I2C port on this revision, but I have fixed that in the production revision. And I think that is about well, you'll notice the headers kind of look like they got their teeth knocked out. I ordered headers from Major League Parts, but or Major League Electronics, sorry. And they have not arrived yet, so I had to make do with what I had. And it's kind of makeshift, but I'm also kind of fond of it, so we'll see how that goes. And I think that's about it. So let's get started and see how it works. Alright, for this first test, we're going to just be testing the motion sensor, and that's the MPU 9150 from InvenSense, I believe. And this is a pretty cool sensor. It's the 9-axis sensor on the board, and that's right here. And that has a compass, an accelerometer, and a gyroscope all built into one package. And it's pretty easy to use, and it's not a bad price for what you're getting, so I'm pretty happy with it. Let's go ahead and start playing with it. So the first step is to come over here into your virtual machine, and you want to make a secure shell with the BeagleBone Black. So we'll start out with that. I've installed Ubuntu on mine, so the login process is a little bit different than yours probably, but it's a pretty easy change to make. So I'll go ahead and log in, use my password here. If I can get it right. There we go. Okay, so we'll just list the directory real quick. You can see here in my root directory I have one file, the desktop, and then I have another folder. The file is i2ctestmotion.py, and that was just a quick test script I wrote to make sure that I was able to read data from the MPU 9150 and that the data wasn't corrupt. And after that worked, I went ahead and downloaded this set of libraries from a company called Pansenti, and they do a lot of work with the MPU 9150 as well as some other embedded products, and I was pretty happy with their solution, so I decided to just go ahead and use that for this video. So we'll go ahead and change into that directory now. Alright, you can see we've got a few files in here, makefile, a few binaries, folders, just the usual you would expect from a library. The two most, I've already made this program, so I won't go into that right now, but you can see we have two binary files here, the IMU as well as IMU cal, and we're going to run IMU cal first. That's what calibrates your sensors, and you need that to calibrate your accelerometer as well as your motion sensor. So we'll go ahead and do IMU cal now for the accelerometer, and we're going to sudo /IMU cal. And I'm going to go ahead and do help here because I don't remember all the command line options. Alright, so we want to set a sample rate of, let's go with 20, and we'll do the accelerometer first. And I have an issue. Alright, well I'm going to go ahead and restart my BeagleBone Black and reconnect and see if that fixes this issue. Okay, so we're back up here. I don't know what that issue is about. I've been having some troubles. I think I need to add some electrostatic discharge capability into this cape because it's very sensitive to touch, and that can throw the whole thing off really easily. But anyways, getting back on it, we'll go ahead and start the calibration here for the accelerometer. I've already forgotten the commands. Let's see if I can remember this. IMU cal, that's 20 for the accelerometer. And it still didn't work. Okay, I'm going to disconnect and restart the BeagleBone and see if that helps. Okay, so we're back up now. I've unplugged and reset the BeagleBone Black, and I think I found the issue. When I was recording, my lighting came falling down on top of the BeagleBone, and I think it just disconnected some pins. So hopefully it was just a minor issue and wasn't anything serious, but I guess we'll find out, won't we? So, for the third time, we will try and run the calibration. Alright, I've had a few issues on the way while I was doing my testing. Most of them really either manufacturing or just stupid choices while I was testing or assembling the board. All of them are pretty easy to fix and design, except for maybe one. And I just wanted to take a little time to go ahead and discuss those issues now. The first one I wanted to talk about is the motion sensor. So that's right here, just a little reminder. I had this working at first, and I was able to pull data off of it. I was able to get data from the accelerometer as well as the gyroscope. I didn't test the compass, but I think it's safe to assume that if two of the sensors are working, the other one is working as well. And then my work lamp, I'll just go ahead and show you that. This little guy right here, it decided that it couldn't support its own weight anymore and came crashing down and just happened to land on top of the SensorCape. And I didn't think it had done any damage at first, but as it turns out, the motion sensor was not as well attached as I thought it was. It just pulls right off there and sticks back on, as you can see. And that's obviously not how it's supposed to be soldered on there. So I think that one's on the manufacturing / assembling end. The guy who assembled the board had never done parts this small before. So it's safe to assume he probably made a few errors along the way. And that obviously will not happen in production. And if it does, we'll fix it. But anyways, the 9-axis sensor is working, just not right now. The next thing would be my non-contact temperature sensor, I guess, and that's just to the left of the 9-axis, depending on how you're seeing this video. And I thought I knew why this wasn't working. I know I forgot to pour a copper fill whenever I made this board. Whenever I sent it from manufacturer, I forgot to actually fill my copper zones. So I knew that it wasn't going to work correctly, but it doesn't really seem to be working at all. And I'm not really sure that I understand why that is. So I'm going to have to go do some more reading on that one. Obviously, I know about some issues with it, but I'm gonna do some thorough reading and figure out why it's not working like it's supposed to. I am able to read, a few blocks of data off of it, but nothing useful and certainly no temperature information. And then you already know about the light sensor. I mentioned that at the beginning of the video. I didn't get that from Intersil in time to test it, so I don't know if that's working or not. And then the last issue I've had so far would be the buttons right here. I already talked about how I sized the pads too big, but I also seem to have forgotten that I designed them to be active low. So whenever I wrote my test script for testing the button that I put on here, I designed it to be active high, and it didn't appear to be working. So I decided to rip the button off the board, and in doing so, I also ripped up a PCB track right here. You can kind of see where it used to be, at least. So that button isn't going to work anymore. I'm going to go ahead and try again tomorrow on a different button pad, but for now I'm going to go ahead and give up on the buttons. Let's see. I think that's all the issues I've had so far. I know I made that sound like it's not a big deal. I've had quite a few issues. But the next thing I'm going to go ahead and move on to is the pressure sensor. So let's go ahead and take a look at that. For the next demo, like I said, we're going to take a look at the pressure sensor, which is right here. I'll let it get a zoom on that. Okay, as you can see, it's pretty simple, just two capacitors there. And this is a pretty cheap device made by Bosch. And I don't mean it doesn't work well. It seems to be a pretty good sensor. So I'm happy with it, and that will definitely be on the final version of the board. So let's take a look at how it works. And I'm gonna go ahead and go full screen with my shell here. You can see I'm already logged in here on my secure shell with the BeagleBone, and I'll go ahead and list this directory. You can see I got pressure test.py in there, and I'll go ahead and more of that so you can take a look at it. You can see it's a pretty long file. We're only looking at about 8% of it right now. I didn't write this. I just wanted to get it up and working quickly, so I was able to find some code from Adafruit that's actually for a different sensor from this same product line from Bosch, and they are fully compatible sensors, so the code works just as you'd expect it to. So looking through it, we can see you've got your defined registers and other ports and things like that. We've got a few functions for reading calibration data and getting raw values. And then further down we have the conversions from raw values into actual temperature and pressure readings. And then finally we've got our main program here. You can see it just creates an instance of the BMP 180 at I2C address 0x77, and that's the I2C address of the BMP 180. You've got a few defines here where you could change the resolution of the pressure sensor. We'll just leave that as the default right now. And then you read in the temperature, the pressure, and the altitude, and these are true temperature, pressure, and altitude readings. Well, altitude is an indirect calculation. You can figure out the altitude from the pressure, so that's indirect, but the temperature and pressure are read directly from the BMP 180. And then we just output those values. So let's go ahead and see how well it runs on here, and I'll just run it a few times to show you that it's actually updating the temperature and pressure. So sudo python. Alright, and that should work for us. Okay, so you can see we have an initial temperature here of 28.5 degrees C at a pressure of 996 hectopascals, and that gives us an altitude of 141.4. And that altitude is pretty much accurate for the Dallas area, which is where I am right now. So I believe the sensor is working correctly, and I'll just go ahead and do it again to show that it's updating. You can see the pressure changed a little bit, and these are probably just sensor errors. But all right, I'm gonna go ahead and just breathe on the pressure sensor real quick to show you how the temperature goes up as I heat it up. So give me a few seconds here. So you can see as I continue breathing on that pressure, the temperature is going up. I've stopped breathing on it now, and we should see the temperature start dropping again. Yeah, so it may not be quite accurate. That's showing a temperature of 29 degrees Celsius in here, and I'm in my room where we should be at room temperature, which is about 27 degrees C. So I think the calibration data might be a little bit off on this one, but it is working, so I'm happy with it as it is. Alright, for this next test, we're going to go ahead and test the infrared receiver on the SensorCape, and that is located right here. And as I mentioned in the intro, that's a 38 kilohertz receiver, so that just means it operates on a 38 kilohertz carrier frequency, and that's the most common frequency used by your consumer devices, especially things like TV remotes, and that's what I'm going to be using in this example. So let's take a look at the software side of things. Down here in my secure shell, I've already logged into the BeagleBone Black. So let's go ahead and list the directory real quick. And you can see we have the irtest.py in this directory, and we'll go ahead and just more of that so you can take a look at it. Alright, this first line you can see from future import print function. That's basically just for formatting purposes, nothing really important for this demo. Then we import the Adafruit BeagleBone IO GPIO library, and then we rename that to pins. It's a little bit easier to type and work with. Here we set up the pin, the GPIO pin that the infrared sensor is connected to is on pin header 9 and in slot 11. I believe that's right around here. So we just set that up as an input, and then we enter into an infinite loop here, where basically we just check to see if the pin's high, we output a 1. Otherwise, we're going to output a new line. And this is kind of an arbitrary choice. I just wanted something that would be an obvious break from the ones. You know, it's easy to get lost in ones and zeros. So a new line is something that's pretty obvious. So without me blabbering on any longer, let's go ahead and take a look at this. I'll go ahead and start the program. We'll sudo python irtest.py. Okay, so it starts running. I'll just go ahead and hit a few buttons on this. You can see it skip a few beats there when it outputs the new lines. And these are all different signals. I know you can't tell on the stream, but they're all outputting a different pulse. And I'll go ahead and end that real quick. So this will be useful for if you want to figure out the codes on your TV remote. You could easily decode them using this. Additionally, you could make use of your TV remote to control a project. You know, if you wanted to set up your BeagleBone to control some sort of audio output, or set it up as a robot control, you can do a lot of cool things with your infrared remotes like this. And that's a cheap module to include, so that'll be staying in the final version. And I kind of like it, so I hope you will too. I guess that brings us to the end of this video. I'm a little disappointed that not everything worked as I expected, and that I wasn't able to test a few of the parts, but I'm happy with the parts that did work, and I know how to fix the things that didn't work. So I'd say overall I'd declare this as a working project, and I will be able to fix the issues. In fact, most of them have already been fixed. So I'm looking forward to the next revision of the board, and I hope you are too.